talk is about automation, really, about automation about Sigmafine and how automation applies to digital transformation. So basically, I did a little bit of research of what are the main goals of digital transformation as it relates to what we do, because probably they could be more and more concepts, but that was my idea, to prepare something that we can do with Sigmafine for sure. So first, we will talk about the business context, why we want to automate. Probably we cannot automate everything, right? As Vika said, we want to automate everything, but then we need to be practical, and then we need to know what we can do. And then if we are going to do, we need to define a strategy and steps on how to do them. So we will discuss about why we want to automate. Then, of course, you already saw some automated cases, and I will mention a couple more. And then, I prepared this presentation with our industry principal for oil and gas, and he did some of these automation projects. So we put together some techniques and ideas on how to automate things using out-of-the-box, out-of-the-box functionality that is provided by Sigmafine, that you don't need to do anything special to do it. So you just use it and do it. Okay. So that's what I will discuss today. So first, why we want to automate any process? Because we want to maximize the value of information. Data might be just sitting there in a database, and you see that the data is just static. And when it is static, it's not giving us any value, because if we are not going to look at it, if it's just sitting there in the database. But then, if we take some effort and then we streamline that information, we put it in real time, we pull the information and we integrate with all of the different systems that will create our data set that we need to make a decision, then we are getting better, right? Soon we are getting better. And then the last step is we introduce some uncertainty analysis, or we use Sigmafine to do the reconciliation, to be sure that the data is fine, to estimate what we don't measure, etc. And then our idea is to get the maximum monetary value, right? So we're not just doing it because it's fun, we're doing it because it's needed, right? So, and the thing is that there are different challenges. Okay, if we want to do an analysis of, let's say, a fuel efficiency, and we want to track a year, because we have done these projects in which we have the efficiency or an energy consumption using net heating content balance for all of the refinery for a year. We want to have a yearly report that happens automatically. Well, we are going to manage a lot of data, right? Then the other thing that we need to do is that if we have the data available, one of the things is that we need to make it available to the right people so they can make decisions. Like in the E&I case, instead of waiting 30 days, if you have a system that now is doing it faster, of course you want to give that information to the people, and you need to use the right tools. And ultimately, you want to expedite decisions, be faster, more agile, and something that the other thing that we want to do all the time is to be efficient when we integrate systems. So we pull the right data at the right time, etc. So in order to manage large volumes of information, we need to have a good strategy. We need to define the asset model, the attributes, the information, the way that we want to pull them, right? Also, we need to define the granularity of our analysis. If we are going to be doing an automated balance, probably if we are going to be doing let's say, a fuel efficiency project for a furnace, probably 20 minutes could be fine. Probably for a heat exchanger network, we're going to calculate the duties or efficiencies of that probably every hour. So it really depends. So because if we go to more granularity, probably we don't win anything, right? So we are not getting anything extra, but we're putting more effort. So we need to do that. We need to create references to data, all right? So we don't have any people typing anything. We just pull the data out of the let's say PI, or we can pull it from LIMS, right? And then later we need to have a tool that will allow us to see the information in the right context, right? So if we have For example, like the case that Massimo shown about energy efficiency, the customer elected to use Power BI to see the information, right? So the customer is just looking let's say the operator looking every hour, or whenever they need to see, they can see the information. Or you might post back the results to Pi, and because you want to do with that information some other calculations, Pi analytics. Or it could be like in the case of Dow Corning, that they go back to Sigmafine with Excel add-in, or you can always pull. You have an issue, let's say with an automated model, you can go to Sigmafine to pull the information to see where your issues could be. Mm-hmm. So in the integration, of course, we need to integrate between data consumers and data generators. In our case, we are getting an input data. We are getting input data from different sources, and we are a consumer of information, but also we are a generator of information, and then we need to do the right configurations to get the data from the process data historian, do the correct query design for the integration framework. For example, the case of Reliance, we are pulling data automatically with the integration framework from Oracle automatically, right? So, but the structure has to be respected from the other system. The structure, when you are casting into the system that we have, it's important. And also, we need to understand when we are automating, we can never be in a situation that we don't have the data. So if the densities are posted, let's say, with a 10-minute delay, right? Well, we need to create. If we automate a balance, it has to be with that delay, or with a frequency that is adequate. And then to do, automation is inviting us to do a faster analysis and more in-depth analysis of our assets, right? So, but then the thing is also, it has some challenges. So we need to validate automatically the information. And also it's helping us to, if we use some of these prediction tools, machine learning tools, AI, we should be able to do automatic predictions of things as they happen, right? And then, of course, we need to use the tools, right? We need to connect them. We need to be trained. We need to learn how to use them. And something that is very important about automation, about using these tools is we need to empower users, right, by providing the information in the right context, right? So, for example, the case of efficiency, right? We are plotting efficiency versus time. The other case that you saw is we are creating correlations between oxygen concentration and efficiency, right? So those are different. It's the same. Everything is one data set, but it's presented in a different form, depending on the user. So we need to provide the right tools. We need to invest in people, right? So people need to know Power BI, or they need to know Pi system, Sigmafine, and it's important to provide adequate training to know how we do. But in other cases, we need to provide relevant education on why we do, right? Why we do it, and then ultimately, digital transformation is about having a more satisfying experience. So people would like to go to see the information in a nice way. So that's very important in digital transformation. And then, of course, once we have achieved our automation process, our engine is done the calculations, we have the representation, we have integrated with the right sources, then, of course, the users, not the person, not the system, the users will be able to optimize their plant, see the patterns that better increase the capability of the plant or reduces losses, for example. They will be able to manage energy better, like in the case of E&I, improve the supply chain, and having more insight into the process, right? So if we do energy efficiency, suddenly now we have access to information that we didn't know, right? And like we will see in examples. And then, of course, you will create synergies. Typically, Sigmafine can be operated by itself, but we have seen customers that have been doing LP integration, scheduling integration, to be able to close the gap between the different functions. So that's what we mean by synergies, and ultimately those synergies will pay us back, right? Our investment. I mean, some cases were already presented for automation. I will just briefly mention two of them. In the case of this automation project, there is a Sigmafine model that is pulling data from Pi automatically, is doing all of the thermal calculations using equation of state. We are doing the calculation, then we use the Sigmafine energy balance rule to predict the specific enthalpies for each stream, to predict things that we don't know. So in this case, what is the value of this? It's like we can look at the efficiency of the furnace, we can track it, we can try to optimize it. Now we know that what is the degree of vaporization going into the columns, and we can control that because every crude will have different properties, right? So the degree of vaporization is critical for the control of the crude tower, right? Crude unit. So, and then of course, I mean, you are saving energy, you are saving emissions. I mean, you are reducing emissions. So it's a very good way. You know, this is a very, I mean, type of project that has a very high payback and is not very complex from the point of view of like a large refinery where we need to develop a complete model. This is just an asset model with some connectivity. And then also there is this case of this purification column where you can compute, you can perform a mass balance and then validate meters. You can perform component balance to look at the purities and validate the purities, and also perform an energy balance having all of the information that you need. We have in the thermal library all of the correlations that I needed. So like the Redlich-Kwong, equation state, Penn-Robinson. We do all of these mixing rules with all of that information, and then we can compute energy in reconciled measure basis, energy in reconciled basis, and that's another example of automation. And these ones are just some of the, I mean, the technical aspects that are challenges that happen when you are doing these type of projects, right? So we create some categories for them, and then just some ideas on how this can be tackled. I mean, how can you tackle these challenges using out-of-the-box functionality, right? So the issues that you typically have is that you have, sometimes you don't have data, right? Bad data, missing data, out of range, you might have spikes, freeze, you have data, might have data freeze, unsteady state. The thing is this, reconciliation uses the concept of a steady state. So if you are not in a steady state and you're going to calculate efficiency of a furnace, I mean, there is no point in doing it because it's not going to work. So you can detect these both aspects, and then all other aspect is not knowing information because we cannot measure everything. Then we use Sigmafine as an observer and as the estimator for those states. So in general, it's very simple. So you just gather information, right? And then you apply a data validation rule. And then the validation rule is going to provide either a validated value, a calculated value, a replaced value, and then Sigmafine will take it into the model to perform all the calculations for the particular model. For example, in this case here, we are trying to avoid bad data. So we can use from the PyPoint data reference that comes with the system. We can configure that if there are not enough values, don't consider this value. If the data is bad, don't do it. So it's basically by configuring a group of attributes, we can say use this value or don't use it, right? So. And then replace it by something else. It could be a default value, for example, like a density. Of course, we need to be careful of what we use as defaults because we need to do those more for properties and things that won't impact too much into into the balance, right? Also large deviations, right? For example, like I said, in the case of densities, you might want to have some maximum minimums, and if the maximum is reached or the minimum is reached, you use the standard calculation for density, and that's just using the formula that I referenced that is built in the software. So that's very, very easy to do. And then something that is important is that if you go to calculations that are very frequently, let's say you're doing energy efficiency for a furnace, probably you cannot do once a minute, because you might have spikes in the data. You might not have even a steady state. So the aggregation is important. So you need to define that you want to get the total of for that period, right? So that will cancel out the spikes, and then you will be able to have a more stable calculation. And then some of the things that are important, as I mentioned, is that you need to detect. One of the things that in automated data reconciliation is the concept of steady state detection. So if you can establish, you create a call for the standard deviation of a particular measurement, then you compare the standard deviation from one period to another, and then you say, well, from right now we are not in a steady state, so we will skip the calculation. Other cases, data freeze is a big problem. I have seen projects where we had a problem with composition. Well, we had a data freeze, and the data freeze was from 5 years ago. So it's funny that sometimes we see a data point, but the data point is not. We get it, but it's very old. So probably even in our projects that are just yield accounting projects, we can get some ideas into data, let's say, evaluation of data freeze. That's something that can be done. All right, and then, of course, that you can use engineering calculations. We had customers that, for example, when they pull the status of a valve, and then if the valve is closed, and the value is below some certain number, we close it, we just put it in 0. Also, for example, for heat exchangers, we might use what we have available, and then we can ask Sigmafine for the rest of the variables that we don't know, like temperature. If we don't measure all of the two cold and two hot sides and two cold side temperatures, the 4, we have 3. Well, Sigmafine will help us to estimate the other one. And then, of course, we can use thermal properties to estimate loss, etc. And then finally, in terms of adding redundancy, in the case of the energy efficiency, in order to estimate the degree of vaporization, we are using temperature, pressure, composition, and vapor liquid equilibrium to estimate. For example, in this case, in the left, you just have one variable. That's not enough information to know what is coming out as vapor and liquid. But once you apply the relationships, the VLE, right, and then for those conditions, you will be able to estimate and then get more information. So you will have a little bit more, probably not redundancy, is more observability, right? Because it's not redundant. So we basically, with the end goal for any automation project is something like this, that we will be pulling data from Pi. We will be pulling data from other systems. It could be LIMS, let's say. Then we use integration framework. We automatically connect to Pi. We schedule the models, right? So to be running at a certain frequency, and then the result is something that the user just sees. They don't need to operate the model. They are just looking at the data out, the data in, data out, and then you can create any nice web dashboards and BI displays, and etc. So basically, as a conclusion, right? So Sigmafine, when you automate Sigmafine, it makes it more appealing to operations, right? Because it's something that is done automatically. I don't need to be sitting there and typing information. I can be applied to meter validation, monitoring, let's say, of compressors or energy equipment that uses energy, right, or produces energy. Then support energy initiatives as well. And basically, Sigmafine is a platform, right, that will allow you to do yield accounting and then support you doing different models for asset optimization, for fuel efficiency, and a heat exchanger network analysis, etc. So that's those are my conclusions, and I will be happy to answer any questions. And thank you very much for attending the event.